Hi everyone, I'm Comet Christina and welcome back for lesson 2 of Abracadabra. Today we're doing incredible inertia. You're going to need your incredible inertia kit, and then from home you're going to need a pair of scissors, some paper towels, some water, something to cover your table, and then as a reminder, today you're going to need some eggs for your lesson. You're going to need about 2 or 3 raw eggs and then 2 or 3 hard-boiled eggs. There are some instructions in your curriculum for how to create those hard-boiled eggs. You want to cover them in about an inch. Make sure they're covered by about an inch of cold tap water. You're going to bring that up to a rolling boil, and then once it's at a rolling boil, you're going to reduce that heat and leave them kind of simmering for about 10 minutes. And then you want to cool them completely to make sure they're safe to touch before we get started. All right, so collect everything that you need, and then we're going to go over some science concepts and get started. Hi guys, Comet Christina here, and we're going to do a really cool experiment called egg in a bottle. We're going to do this one as a demo because we are using fire, which is definitely not something safe for anyone other than an adult to do. So let me ask you a question. I have this peeled hard-boiled egg here, and I have this bottle. So I'm going to see if my egg can fit inside my bottle. It doesn't, and I don't really want to squish it into the bottle, and that'll break up the egg and be kind of icky. So we're going to see if we can use some science to help us make this happen, and maybe even a little bit of magic. So I have some cut up scraps of paper. I'm going to fold one in half, and I have some matches here. This is where the fire comes in. And I'm going to tear off a match, and I'm going to light it, and light my piece of paper on fire. Let that burn for just a little bit, and then we're going to quickly put it into the bottle and then stick our egg in. And our egg got sucked up into the bottle. We're going to do that one again in slow motion. Okay, so that was awesome. So I don't know if you saw in the video, I even kind of jumped back a little bit when I put the egg on the top because it actually shook not only the egg, but my whole table. So what happens is when we heat things, in general, they tend to expand, and when they're cold, they contract. So when we dropped that piece of paper that was on fire inside of the bottle, it caused the air molecules to sort of expand. When we put the egg on top, some of that air was escaping, and the air inside the bottle was then cooling down. So it actually created a lower pressure inside the bottle than outside of the bottle. So it actually created kind of like a vortex, and that's what pulls our egg down into the bottle. So that was pretty neat. I hope you guys enjoyed that, and let's move on to our other inertia experiments. All right, so before we start on today's hands-on activities, let's talk about some of the science and concepts we're going to be covering today. So the first one you need to know about is density. Density is the measure of how much mass there is in a certain volume. And volume is the amount of space that something takes up. One concept in science we're going to be putting into practice a lot today is Newton's first law of motion. And that states that an object at rest will stay at rest unless acted on by an outside force. An object in motion will stay in motion at the same speed and in the same direction it was going unless acted on by an outside force. So that basically sums up the concept of inertia. So inertia is an object's tendency to either stay at rest or stay in motion. So you're going to see that a lot through today's experiments. Before we get started on our hands-on activities though, we're going to show you a video demonstration of something called egg in a bottle. Now the reason we did this as a demo is it does involve fire, so we wanted to make sure it was something performed safely by an adult, but you guys get to watch it and see a really cool science trick. So let's go ahead and get started on that video. All right, now it's time for our first hands-on activity. This is called super spinners. So you're gonna need 1 hard-boiled and 1 raw egg. So I have one of each here with me as well. And just from looking at them, I really can't tell which one is which. They're both in their shell, they both feel about the same. I can't really tell a difference, but we can actually use science and Newton's first law of motion to help us determine which one's raw and which one's hard-boiled. So when we have a raw egg, we have a hard shell on the outside, which is a solid, but then on the inside we have liquids. We have the egg whites and we have the yolk. When we hard-boil an egg, those liquids turn into a solid because it becomes cooked. So in Newton's first law of motion, an object in motion wants to stay in motion unless worked on by an outside force, and an object at rest wants to stay at rest unless worked on by an outside force. So in theory, if we have a liquid egg, what happens is when you are spinning an egg, the outside will slowly start to come to a rest. But the inside that's still liquid does not have those same outside forces on the outside of the shell that the insides do. That the outsides do. So the outsides have these forces working against it, the friction of the table, the air around it, makes it come to a stop. The insides don't have that, so the insides want to keep spinning. Whereas for a hard-boiled egg, when we are spinning it, nothing is really working against those inside forces differently than the outside. So in theory, a hard-boiled egg should spin better than a raw egg. So we're going to put it to the test. I want you to do the same. If you know which of your eggs is raw and which one's hard-boiled, mix them up a little bit. See if you can kind of start fresh and use just the spinning to help us determine this. And then we're going to make a hypothesis about which one is raw and which one is hard-boiled. This is also why you want to make sure you have your surface covered and it's a nice flat surface to do your spinning on, because there might be accidents. In fact, I may or may not have already broken an egg filming this part. So we're going to start with this egg. We're going to call this egg number 1, and we're going to spin and see what that looks like. Okay, so this egg's not spinning so great. There we go, that was a pretty decent spin. And it looks pretty wobbly when I'm trying to spin it. Okay, and it comes to a rest pretty quickly. So let's try this with egg number 2 now. Let's see if there's a difference. Okay, that one spins really well. Really, really well. Okay, so according to what we just talked about, I think that this one is the hard-boiled egg and this one is the raw, but we're going to find out for sure. So I'm going to bring a bowl over here and I'm going to crack this egg. So this was egg number 1. This egg did not spin very well, so I think this is the raw egg. Let's find out. Yep, that is definitely a raw egg. So that means egg number 2 must be our hard-boiled egg, right? Let's find out. Yep, I can tell already. That's definitely cooked. So we just used inertia in Newton's first law to help us determine this. So if you're ever in a bind, if you have hard-boiled eggs and you have some raw eggs and you can't figure out which is which, you can use this really neat science trick to help you determine which eggs are cooked and which eggs are not. Okay, now we're going to do a different experiment talking about inertia. So from your kit, you're going to need your 3.25 ounce souffle cup, your piece of construction paper, and then from home, you're also going to need a pair of scissors and some water. So I'm going to show you a close-up of this one so you can kind of see how it works. But to start, first we're going to take our water and fill our souffle cup about halfway full. Okay, and then we're going to take our piece of construction paper and we're going to want to cut a strip about 2 inches by 11 inches. So really you want to cut it kind of this way and about 2 inches wide, just one strip. So it should look just like this. And then I'm going to do a close-up so you can kind of follow along with this activity and see the step-by-step process of how this works. Okay, have you ever seen in like a movie or a cartoon where they have this big table set with all these cups and glasses on it, and there's a tablecloth underneath of there, and someone's able to rip the tablecloth off without spilling any of the glasses? Well, this is exactly the same concept. So you need to be near the edge of a table. You're going to take your cup of water and set it here near the edge. And you're going to take your strip of paper, set it underneath your cup like this, near the edge of the table. Now it's important that you have a good bit of the amount of paper sticking off the edge of the table. You want at least half of it hanging off the edge of the table. And the trick to making this work is we want to make sure that we grab the paper. We're going to be pulling it very quickly and in a downward motion. So we're going to see if we can do this without spilling our cup of water, because that would be messy. All right, so let's see if we can do this. Ready? Okay, that was pretty good. Let's see if we can do that again. The trick is you really want to be really quick about it. You can't kind of pull it, you got to pull it fast and downward. Ready? Okay, my water barely moved. Did you get the same results? Okay, so was that science or was it magic? It was definitely science, and we're using the same concept of Newton's first law of motion and talking about inertia. So when the cup of water was at the edge of the table, it was an object at rest, and so was our piece of paper underneath of it. But when we pulled it out, were we putting the object in motion? And were there any forces working against the cup of water? The answer is yes, but because the piece of paper is so slippery and so is the surface of our table, we really weren't putting very much forces against our cup of water. There was not a lot of friction, not a lot of things happening, and the paper was easily able to kind of slide out from under there. So our object at rest wanted to stay at rest. All right, now we're going to do our golf ball drop activity. So from your kit, you're going to need your plastic plate, your golf ball, one of the clear 16-ounce cups, and your toilet paper roll. From home, it's probably not a bad idea to have a covered surface here if possible. If not, that's okay. You probably want some paper towels in case there are any messes, and you do need some water. So I'm going to talk you through this one and how we're going to set it up, and make sure you follow directions carefully for this one. So the first thing we're going to do is we're going to take our water and we're going to fill our 16-ounce cup about 3/4 full. So about there. Okay, and then we're going to stack these items, and we want to make sure that things are as centered as possible. So first you're going to take your plate and you're going to try to put it as centered as you can on your cup of water. Next is the toilet paper roll. And again, you want to make sure this goes on the center of the plate. And then lastly is our golf ball. So we have quite the structure going on here. And what we're going to do is we're going to take our hand and we're going to move it horizontally to push the plate from on top of the water. Now when you do this, you want to make sure you're not hitting the water. You don't want to hit the tube or the golf ball either. You want to hit just the plate. It has to be a quick motion. And it's really important too that whatever you're pushing it towards, make sure it's not something that is breakable or could be damaged if you happen to accidentally hit the water and spill it. So it needs to happen very smoothly, very quickly, and in an area where if something were to go wrong, nothing would get damaged. Okay, so before we start that, I want you to think and kind of make a hypothesis about what do you think is going to happen. Because we're just pushing the paper plate. What's going to happen to the cup of water? What about our objects that are on top of the paper plate? Think about what we've learned already about Newton's first law and inertia, and make a hypothesis about what's going to happen. Now I'm going to do this activity myself so you can see the results, and it's going to be in a close-up, but you can also do this at home once you've kind of made some guesses about what happens, and we're going to find out if you're right. So that was pretty neat, and I don't know about you, but I kind of felt like a ninja. Okay, so is that what you thought would happen? Did you think that the golf ball would just drop straight down, or did you think it would fly across the room? So when we learned about inertia, this golf ball, when we had our structure set up, was our object at rest. So even though we applied force to the plate and we did end up moving the toilet paper roll, our object at rest wanted to stay at rest. And if you look at the video, the golf ball actually, for just a split nanosecond, didn't move because it didn't want to move. But then gravity took over and it dropped it down into our cup of water. So you can kind of play with this experiment a little bit and see what happens. What if we added less water to the cup? What if we added more? What if our tube was shorter? There are some different kind of variances that you can add in and see if you get different results. All right, now we're gonna do a magic trick called the floating egg. So from your kit, you're going to need both of your 16-ounce cups. So you will need the cup we just used for the golf ball drop. You're going to need your bag of salt, and you're going to need your plastic spoon. From home, you really probably should have your table cover because we are going to be pouring liquids. You're going to need 2 eggs. They can be raw or hard-boiled, doesn't matter. And then you are going to need some warm water. So it doesn't have to be super hot. Probably just warm water from your tap is fine. So to start our experiment, you're going to fill up each of your 16-ounce cups until about 3/4 of the way full. You can actually probably even use that line that's right there at the top to mark about how full that is. Okay, now this is important because we're going to add salt into one of the cups, but you'll just need to remember which cup we added the salt to do your magic trick. Because this is something you can do. We can do it now, but if you want to do this later on as a magic trick to show others, you'll have to do this part before you show them. And this part is adding all of the salt into one of the cups and then using our spoon to mix that in. This is why we needed the warm water, so that we can help that salt kind of really dissolve. Okay, that's pretty well mixed in. Perfect. All right, so now I'm going to add one of our eggs to the cup that does not have salt in it. And we're going to see what happens. Make a hypothesis. Do you think your egg will sink? Will it float? Let's find out. All right, if you can see here, our egg is all the way sunk right down to the bottom of the cup. Now comes the magic part. I'm going to set this cup aside. We're going to do it again in our cup that we added salt to. Do you think we're going to get the same result? Let's find out. Abracadabra! So in this cup, our egg is floating on the top. So it might seem like magic, but there is science behind this. And it actually involves some of the concepts we talked about earlier. So when we added the salt to the water, it actually increased the density of the water. So these 2 cups were the same size and they had the same amount of water in them, so their volume was the same, right? So when we actually dissolved the salt in the water, we added more mass and it became more dense. So that density that we talked about earlier. So because this water is more dense, that is why the egg actually floats on top and why it can't sink to the bottom, because the water is actually denser. So this is just a really good example of how something might look like magic, but usually there's science that kind of can explain why something happened. All right, guys, now it's time for our last magic trick. This is called the big squeeze. So from your kit, you're just gonna need your clear plastic Ziploc baggie, and then from home, you need a raw egg. So have you ever broken an egg before? I've broken plenty. In fact, I broke some while I was filming these lessons for you guys. So I think everyone kind of knows that raw eggs are pretty fragile, right? So before we get started, one important note is if you have any kind of rings on your finger or jewelry on your hands, you should take that off before we get started. Okay, so this one's pretty simple. All you're doing is you're going to open your Ziploc bag and you're going to gently put in your raw egg. I'm going to put mine here in the corner. And then we want to make sure we get all of the air out of our baggie. So the way I do that is I seal up the first half of my zip, and maybe like I leave about a quarter undone. And then I'm just going to gently squeeze the bag to push all of that air out through that tiny little opening that's left. And then I'm going to seal up that last little part. And then I'm going to double check and make sure the whole thing is sealed. All right, so it should kind of look like this. Mine looks almost like vacuum sealed. If you look at it from the side, it's really flat because there's no air left in there. So that's exactly what we're looking for. All right, so now in our plastic baggie, we already talked about how eggs are pretty fragile. I want you to take your egg in your hand and I want you to squeeze. Try to apply a pretty even pressure and just squeeze it like you're gonna ball up your fist. Before we get started though, what do you think? Do you think you're gonna be able to break the egg? Let's give it a try. Okay, I'm squeezing mine pretty hard and it's not breaking. Okay, did you guys get the same result? So let's talk about why that happened. So when you look at the shape of an egg, it's the same shape as a 3D archway, which is actually one of the strongest structures. So as long as you apply even pressure to it, that's why we wanted to make sure we didn't have any jewelry or anything to, like, you know, when you crack an egg, I'll sometimes do it on the edge of a bowl. We didn't want to have anything like that because that is actually what causes an egg to break. So actually structurally, eggs are pretty strong as long as you apply that even pressure. All right, guys, that plastic baggie should have protected our hands, but if for any reason you did get some raw egg on your hands during that last activity, just make sure you wash it off with some warm soapy water. That was it for our incredible inertia lesson. I hope you guys had fun and learned a lot. I'll see you in the next lesson for Bag of Tricks.